Today we do the elimination method, and we take 2 days on that, today and tomorrow. So today's like the very basics of the elimination method. So review, which we've already done, right? So I'll gloss over this because we just talked about that. So here are the steps for elimination. At first, usually with elimination, the equations are in standard form, right? So ax plus by equals c. Before you start, both of them are in standard form. The variables are lined up. Okay. Now, the next step is what we get to next class. We won't have to do this in this lesson today. So we'll skip over the step 1. Okay. So step 2 is going to be, we're going to add the equations or subtract the equations so that we eliminate a variable. That's why we call it elimination. I want to get that light switch. That one, yeah. Right? Just like when we did with substitution, right? We substituted for one variable into the other equation. We reduced it to one equation and one variable. That's what happens in step 2 here. We add or subtract the equations to eliminate a variable so that we just have one equation and one variable. Okay, and then we solve for that. Whatever's left, we solve for that. Okay, then we're going to have to find the second variable. So we'll take whatever we got on step 2 and we'll go back to one of the original equations and substitute it, solve for the second variable. Okay. So, for example, you can see these are standard form. Ax plus by equals c, right? The variable terms are lined up. Okay. Now, in this particular problem, should I add the equations to cancel a variable or subtract the equations to cancel a variable? Which variable looks like it's going to cancel? The x's, right? And so how should I do that? Should I add these two? Yeah, I mean, this is an add. When they have the opposite sign, then you add them to cancel a variable. So, right. So again, step 0 was they were in standard form. Step 2, it looked like we're already ready to go on to step 2, which is if we add these, it's going to cancel the x's. It's going to eliminate the x's. So let's do that. We're going to plus, plus, plus. Okay, and so these give us 0. These cancel. This is going to give us 8y, and it's going to give us 24. Okay, so now we've got one equation, one variable, solve for that variable. Y equals 3. All right, are we done? No, that's just the first variable, right? We still got to get the second variable. So where are we going to go to get the second variable? In this method, it's not as obvious as it is with substitution. Because substitution, you got one place to go. It's whatever you had at the end of step 1. Here, you've just got to pick one of these two equations that you want to plug that into. Right? There's no one right answer. Somebody might want to use this one. Somebody might want to use that one. You know, I would probably pick the first one because I don't see any negatives involved, but it doesn't really matter. So let me go up to the first one. And we're going to get 2x plus 3 times 3 equals 11. 2x plus 9 equals 11. Subtract 9. 2x equals 2. X equals 1. Okay, so now we're done. We got the x and the y coordinates. The point, the solution is 1, 3. Yeah. They should be lined up. They honestly don't have to be in standard form. They could be on the other side. But most of the time when we do them, it will be pretty straightforward, like ax plus by c. Because you could see that if you do, it will cancel a variable. 2x plus negative 2x, 0. You know what I mean? If you add a number and its opposite, you get that. So I think the next one is for you to try the same thing. Try to do the same thing on that one. Right? In this case, we're going to add them up. And which variable is that going to cancel? The y's. So we're going to get 4x plus negative 2x is 2x. Right? The y's cancel. Negative 2. Divide by 2. X equals negative 1. Okay, then go back to one of these equations. It doesn't matter which one. I'm going to go this one right here. Negative 2 times negative 1 plus 3y equals negative 7. Positive 2 plus 3y equals negative 7. Subtract 2. 3y is negative 9. Y is negative 3. So the solution is negative 1, negative 3. Yeah. Yeah, you add if that's what it takes to cancel a variable, then you add. Okay. Okay, now in a problem like this, would it work for me to add these two and cancel a variable? No, because they have the same sign, so I got to subtract. So you got to do what's appropriate for the problem. In this case, we're going to have to subtract one line minus the other to cancel the y's. So let's subtract. Right? 4x minus 5x. Negative x. The 3 y's cancel. What's 2 minus negative 2? No. Positive 4, right? Minus a negative makes it a plus. Okay, so we're not done solving yet. What does x equal? X equals negative 4. Okay, now we do like we did on the last one, right? Go substitute into one of these two. It doesn't matter which one. I'll take the first one. So 4 times negative 4 plus 3y equals 2. So negative 16 plus 3y equals 2. Add 16. 3y equals 18. Divide by 3. Y equals 6. So here's our solution. Negative 4, 6. All right, so try this one. Okay, so what should you have done to cancel a variable in this problem? Subtract, right? So subtract. 7x minus 7x cancels. What's negative 2y minus negative 3y? That's like saying negative 2y plus 3y. It's just y. Y equals 1. In one step, you just solve for y. Okay, then you got to substitute that. 7x minus 2 times 1. Okay, let's see what's next. Okay, what's different about this problem? It's not in the standard form yet, so we need to like get it in standard form so we could use the method, right? So which one of those do I have to move? The second equation right here, right? This is in standard form. That one is not. So if this is if I want to get this 3x onto this side, if it's a positive 3x here, what's it going to be on this side? Negative 3x. So either subtract it from both sides or just use that kind of thinking. Now, it probably would help if I rewrite this first equation. So 8x minus 4y equals negative 4. Okay, then this is going to be negative 3x plus 4y equals 14. So if they're not in standard form, do it. Yeah. I mean, in the end, if you like put them both in y-intercept form, then you'd have y equals this and y equals that. Then it's really more like substitution. You know what I mean? But I mean, Connor's asking a good question. I think somebody else kind of asked it before too. But you could have, if you would subtract 8x to the other side, then you'd have negative 4y equals negative 8x minus 4. And although it's not quite in standard form, it does actually have all the variable terms lined up. And you could have added them and canceled the y. But normally we try to make it standard form. So now we're all set to go, because if I add these up, I cancel the y's. 5x equals 10, x equals 2. Okay, and then I got to go back to one of the original equations. I think I'll do this one right here. 4y equals 3 times 2 plus 14. Right? 4y equals 6 plus 14. Okay, so the point is 2, 5. Okay. Let's see there. John's done? Okay. Okay, so try to do the same thing with that one. Doesn't look like it's quite in standard form yet. Right? It should have been 1, 2. Right? You should have subtracted the 4x to this side. And then in order to make the 5 y's cancel, you had to subtract. So you've got to subtract 2x minus negative 4x is like 2x plus 4x, 6x. Right? And I saw some mistakes on that, but that's why subtraction is always a little harder than addition. Yeah. Katie, you done?